This strategy I'm going to show you is a strategy that is a little bit new. It's an analysis type strategy. It's not going to be one of our go-to strategies in grade 11, but it is very important for us to start to understand that there are other ways that we analyze math other than just kind of solving algebraically and things like that. So in grade math 12 and in calculus, we need to build arguments and we need to have some strategies for analysis. And sign or case analysis is one of the strategies that we use quite extensively. So it's good to understand how this works and just understand that there are different ways to analyze mathematics. So this sign analysis works in this way. So I have my my quadratic one variable inequality. There's my inequality. So I need to know my boundary points. Okay, so my boundaries are going to be -5. And I also have boundary at +3. So I've marked out the boundaries on two separate number lines because I'm going to use the different cases here. And the cases are going to be when I'm looking at the signs for x minus 3, I'm going to just ask myself, what are the different values, positive or negative? And this is all I'm going to test here. And this is part of the case analysis. It's just generally testing some main ideas, not specifically testing, narrowing down on some certain number. We're just testing for either positive, negative, above 0, below 0. And this is a very powerful and useful analysis. So when I look at the factor x minus 3, I know that if I plug in a 0 into that expression, I'm going to have a negative value for that bracket. If I plug in a number bigger than 3, I'm going to have a positive value in this bracket. And then over here, I'm going to have negative. So boundary really is just 3, so I know on this side I have negative, on this side I have positive, and my 0 ends up there. Then I do the same thing for the x plus 5 bracket. Okay, and I could actually do this for multiple factors. So I'm going to test x plus 5, just check. If x is less than -5, it's going to be negative. Okay, so for example, -6 plus 5, yeah, it's negative. There's our 0 here, so everything on this side should be positive. So if I plug in 0, I'm going to get positive. If I plug in 19, I get positive. Okay, so there's our boundary here for this factor. There's our boundary here for this factor. So what we're going to do is we want to know where this quadratic is less than 0. Really, we just need to know when the quadratic is negative or positive. So what I'm going to do then is I'm just going to combine these factors vertically. So when I combine the factors, x minus 3 is negative when x is -6 or -7 or -8. This is going to be negative as well. So when I combine these, and I'm going to choose a different color here, when I combine these like this, I end up with a positive on this boundary here. Okay, so that does not satisfy that inequality of less than 0. Then I test this region here. Okay, when x is 0, I'm going to get negative, positive, so negative, positive. So that's a negative. That satisfies my inequality. So I know that my inequality must include this region here. So I'm just going to put a little arrow. I'm not sure where I'm going to stop. So here's the other boundary line. When I combine the factors like this, so if I plug in 4 and 4 here, positive, positive, positive times positive is going to give me positive. Okay, so then that's not part of my solution, so my solution is going to be in this region in here. And I can see that when I combine the factors, this negative factor here, when the x values are in between -5 and 3, I get my solution. Okay, so this is the solution is going to be this when I've combined these cases like this. Okay, so I'm just looking at the individual cases of each factor, combining them. In this case, we're combining them by multiplication, so we just need to see what's happening in multiplication, and all we need to test is above or below 0 or positive or negative. And that makes it analysis relatively simple, but it's just a different style of analysis that we use. And this is called case analysis. So let's try this one here. So let's try the same thing. We're going to factor this first. So I need to make sure I can factor this. 2x squared negative 10x squared. Two numbers that multiply to negative 10 and add to positive or negative 3 are going to be positive 2, negative 5. So I get 2x minus 5, x plus 1. So when I factor this, I get 2x minus 5, x plus 1 is greater than or equal to 0. Okay, we know we have a 0 at negative 1 and positive 2.5. Okay, so we can test our two factors, and we can test our signs here. For the 2x minus 5, we know that this is our 0 boundary. And so when I go to the right, I know that's going to be positive, negative, negative. Okay, and I can just check by plugging in some numbers. 0, yeah, it's going to give us negative. If I plug 10 into here, I get positive. Okay, so there's my sign analysis for that factor. And I do the same thing here. Now, really, again, the key is the 0. So if I just kind of mark my 0 there, there's my 0. Okay, and then on the right-hand side, when x is going to be 0, I have positive, so I know it's positive on this side. And if I plug in numbers less than negative 1, I'm going to get negative. So then I combine my factors. These are being combined in multiplication. I want to see if it's greater than 0. If I combine this, I get positive on the left side of negative 1. Okay, so I know it's equal to 0 here, so I know that that must be part of my solution. It's above the x-axis. I'm going to combine these. I get negative in here. Well, negative is going to be not less than 0. It's bigger than 0. It's less than 0, so that's not part of my solution. And there's my 0. So again, there's another boundary. And when I test those, if I multiply these two factors together, I get positive times positive, which is positive. That is greater than 0, so that satisfies my inequality. So I know that all the solutions less than negative 1 and bigger than 2.5 are going to give me positive values. And again, if we imagine what this looks like, it's a parabola facing up through those zeros. Yeah, that parabola, the parts above the x-axis, yeah, that we can confirm that with our graph analysis as well. So we have multiple ways we can check these things, and we should always be double checking these and making sure these different ideas match together, because it allows us to make connections, which then allows us to use these different concepts in much more a bigger variety of ways.